Hi there, my name is Caitlin Larson. Welcome to my restaurant app capstone presentation. Uh, this first part is going to talk about the front-end architecture, authentication, and the app diagram. User experience and security are at the top of the priority list when it comes to developing an e-commerce app. To create a food ordering app, several choices were made to keep the end user in mind, all while ensuring the app remains scalable and secure. From the architectural choices in the component design to the implementation of user authentication and payment process, every step was marked with extensive learning. So now let's get into some of these technical details. The cart, and checkout form JSX files all provide the user with the shopping functionality. Being able to add or remove dishes, access the payment form, and ultimately check out their order creates an optimal user experience. The layout, loader, and form JSX files give the overall site functionality with the header and menu, the sign up and login forms, and how the user transitions through the information with their clicks. Lastly, the restaurant list and the dish list give the user the ability to see an image, description, and in the case of dishes, a price, which are all essential to a food ordering app. The UI prioritizes user flow, allowing customers to seamlessly navigate from selecting a restaurant, viewing its dishes, adding dishes to their cart, and finally proceeding to checkout. The separation of cart and checkout cart gives a two-step confirmation process, which can reduce accidental orders and provide a clear review of selected items. The dedicated loader component ensures that users are always informed about background operations, improving user experience during data fetching or transaction processing. Next.js offers tools and functionalities that not only improve performance and SEO, but can also influence the component design and the data flow for a better user experience and maintainability. Tools like server-side rendering allows the site to fetch and display the latest data every time they're accessed, which ensures the latest dishes in restaurants are always shown. As well, Next built-in link component allows for seamless navigation between pages without doing full page reloads. To create secure user authentication, I integrated JSON Web Tokens. Since this generates a unique ID to each user, it ensures that the server recognizes the user each time they log in. And since tokens carry all the necessary information for validation, the database doesn't get repetitively asked for verification. Merged with the capabilities of Strapi and GraphQL, user registration and login processes create a smooth user experience. With Strapi, when the user signs up or logs in, two things are generated. The first is the token, which acts as a digital signature. It maintains user privacy and makes sure the data they send or receive is unaltered. The second is a user object, which acts as a digital profile card. This allows for the user email to be displayed in the website header while logged in. Additionally, the cookies.js library was added to act as a secure vault on the user's device, storing the token and ensuring that the user remains authenticated on subsequent visits. Lastly, Strapi's built-in features allow for efficient user management. It handles sign-up and logins, but also offers an interface where developers can manage the user profiles. For me, multiple attempts were made to add the additional option of authorization, either with Google or Facebook. First, I tried Firebase, but I was unable to create communication across the platforms. So then I tried adding from Google Cloud's OAuth service by creating the app and then creating credentials. Ultimately, I was very unsuccessful. In the future, I intend to practice with more authentication tutorials to get a better understanding of how to implement them. Stripe, which is renowned for security and developer-friendly features, was selected as the payment provider to create a seamless e-commerce experience. Through Stripe's API, the app processes user payments, and upon approval, the funds are eventually transferred to the associated bank account. Stripe ensures all transactions are encrypted and compliant with payment regulations, providing peace of mind for both developers and end users. Initially, for me, distinguishing between Stripe's live and test platforms was a hurdle. I didn't want to accidentally mix up the functionalities between the live and testing keys, as it could lead to unintended real charges. To differentiate between the live and test environments on Stripe, I had to do a lot of research and triple checking as I went. Also, grasping the concept and importance of using .env files to protect Stripe sensitive API keys was another challenge. Exposing these keys publicly could compromise the security of transactions and potentially lead to financial losses. So understanding the importance of .env files was crucial. By diving deeper into it, the research and their usage in Next.js, I was ensured that the API keys remained private and weren't exposed in the code base. So online resources, community forums, and best practice guides were really invaluable during this learning phase. And that finishes off part 1.